Hi, and welcome back. In this third video of my Kubernetes series, we will install a pod network. The pod network, although listed on the Kubernetes website as an add-on, is required to allow Kubernetes pods to communicate amongst each other. The pod networks uses the settings that you defined while setting up the cluster to assign IP addresses to pods, services, and other components, but also allows you to set networking options and enforces network policies for your cluster. That last feature goes a little far for this series, but I might look into this functionality in the future. I will be using the Calico network. So let's go to their website and take a quick look. The page was not easy to find, but it shows everything you need in order to set up your cluster. As you can see, it is super easy and really straightforward to install that network. Only 3 steps are necessary to set up that functionality. At first, you install the operator on your cluster, then you download the custom resources and customize those to your liking and needs. And last but not least, you apply those custom resources to your cluster. That's it, and you have a pod network installed. So let's head over to our terminal and deploy the operator. As you can see, I split the screen into 2. On the left hand side, I will enter the commands and deploy items, whereas on the right hand side, you will see the changes this deployment has on your cluster. Before we deploy our operator, as we expect the cluster impact, let's start to watch the cluster and see what happens. To watch what happens with your deployment, just enter watch kubectl and then whatever you want to watch. In this case, get nodes, as we expect the impact on the cluster to jump from not ready to ready. That's why we're watching that piece of information. And now we can actually copy the information from the website that we just took a look at and deploy it in our cluster. And then you get the output of what happens, and we see that a lot of items have been deployed. As you can see in the first few lines, there are a lot of custom resource definitions that are deployed. Later on, you see that there is a service account, a cluster role binding, and deployment. Looking again at the Calico website, we see that the second step is to download the custom resources and to then customize these resources to our needs. So let's copy that link, go back to our terminal, and I created a folder to store those custom resources. Oh, that's a little much. Let's do that once. Now we downloaded the custom resources, and now we can update this configuration, deploy it, and then our network should work and our cluster should jump from not ready to ready. If we open up the custom resource file, I have to change the color scheme to make this more legible. If we start looking at it, we have on the top here the API version. That means that's what you're calling once you deploy these custom resources. It's an installation, and by calling the operator here, that's what Kubernetes will find, and then it will take the next steps. So the interesting part here is the CIDR. Now, during the installation of Kubernetes, you defined a pod network as well as a service network. So let's head back quickly to take another look at that. We're going to stop the watch command and going into the cluster setup. You remember that we have a cluster setup, which if we go in here, you find your service subnet, and pod subnet. This pod subnet is exactly what you want to enter here. That way, Calico knows what address range to use when when a new pod is started. That's what Calico is managing, which is why we want to update that to 10.2.44. We will leave the zeros in here, /16. We're going to write this file. Those are all the changes that I'm going to do, and I'm going to exit this file. I'm also going to exit the cluster configuration. I'm going to call the Kubernetes nodes again to watch the nodes. Once we deploy this file, we'll see what happens. First, let's go back to the Calico website. Let's take another look what the next steps are. Alright, create the manifest in order to install Calico. Alright, those are the custom resources we're talking about. Now, all we have to do is deploy the custom resources. So let's head back to the terminals and deploy the custom resources. So kubectl apply-f custom resources. Alright, those are deployed. As we wait for the pods to start up, let's take a look how far they are along. So watch kubectl get all -n Calico system. Alright, where are we? Alright, the Calico Taifa is already running, and we're waiting for the CSI node drivers as well as the Calico nodes. So let's give it some time and see what happens once those nodes and those pods are actually up and running. This is also kind of a nice opportunity to take a quick look at the different statuses. So you see you have containers running, you have init containers, which means they do some prep work for your containers. We will use them in the future as well. Then pod initializing means that everything, the initialization was done, or the init container is complete, and now the main container will start up. Container creating, and again, you have the container that is being created. Those are different statuses that you will find across Kubernetes once you start up deployments. But more importantly, you can already see now that there are some nodes that turn from not ready to ready on the right hand side. This is exactly what we were expecting. So we have master worker 1 and 2 already ready, and the further along we'll get with the deployment here, the more nodes will turn from a not ready into a ready state. So let's give it some more time, and then hopefully we'll have all our cluster ready. What you can also see is that the statuses are currently frozen here. It's not updating. So that means that the server is currently executing a lot of work, and it might not be able to refresh every 2 seconds. I've seen that in the past, and on the right hand side you saw that the server disappeared, or the status disappeared. That's usually a good indication it's coming back. You see it now happening on the left hand side as well. It will come back, so you just give it some time and you should be fine. Running, running, running. Our cluster is completely ready. Even though on the left hand side you still see some containers still starting up, always wait until they are done. That's the strength of Kubernetes. It will take its time, but once it's running, it will restart pods if they fail, and that's what you want. You have very little maintenance, and that will ease your life. And that's why we're doing this exercise here. I think we should be fine mostly. And we're going to stop watching the deployment here now. Calico will do its, or Kubernetes will do its work in the background. Calico will deploy. Our cluster is completely ready. That's what we wanted to go through here in this video. And what we can do as well, we can do a little bit of a deeper dive into the cluster here. There is one option that you can add to every command if you have this watch going on, -o wide. It will provide you with a little bit more information. You will see the name of your node. As usual, you see it's ready, it's the control plane, how old is it, the version, but then you also see the IP address of your LXC container or your virtual machine. Is there an external IP address assigned? We'll get to those a little bit later in the series. You see the operating system of that node. What kind of operating system are you running on? We are running on Debian 12 bookworm. And last but not least, you see the container runtime, which is containerd in version 1.6.22. You can enter this command in every single instance that you have here. So for example, if we take another look on the left hand side and you enter it wide in here, you will also get this information on which node are these containers running. That's always nice to have. Then that command will help you greatly to find that out. That can be an important information. All right. That is all I wanted to cover in this video. Let's do a little recap. What is working? We now have a fully functional cluster that you could start deploying your containers to. What is not working? There is no external storage currently available to your cluster, so everything you deploy would just get lost in case a pod crashes. What's left to do? Next, we will install Helm, a package manager for Kubernetes, and discuss some of its functionality. After that, we will talk about external storage, and we will deploy an NFS external storage provisioner to your cluster. We will discuss the setup of NFS and how it has to be configured in order to work. That's it for this video. Thanks so much for watching, and I will see you in video number 4 to install Helm, the package manager for Kubernetes.